So in this question, we're asked to show that cosec theta minus sine theta is equivalent to cos theta multiplied by cot theta. And this is for 3 marks. So what we're going to do here is we're going to take our expression, we're going to take the left-hand side of it, and we're going to use trig identities and manipulate our expression to eventually come to this term on the right-hand side. So as you can see, I've copied our left-hand side down here, and we'll now write down our first trig identity. So we know that cosec of theta is going to be equal to 1 over sine theta. So that is our first trig identity, which is going to be useful here. So we can therefore rewrite this. This is going to be equivalent to 1 divided by sine theta minus sine theta. So the next step here, what we want to do is we are going to multiply this out. So we're going to have 1 multiplied by 1, which is 1. And then we're going to subtract sine theta multiplied by sine theta, which is equal to sine squared theta. And then for the bottom of our fraction, so the denominator, we're going to have the denominator in this fraction multiplied by the denominator in this fraction, which is going to be sine theta multiplied by 1, which is going to be equal to sine theta. So then we have to think, now we've combined this into one single fraction, what's next? So we know that sine squared theta plus cos squared theta is equal to 1. So therefore we can say that 1 minus sine squared theta is going to be equal to cos squared theta. And we have this 1 minus sine theta here in our numerator. So we can then substitute this in. So we have that this expression is going to be equivalent to cos squared theta, and we divide this by sine theta. So the next thing that we're going to do, so we note that we have a cos theta term here. So we're going to just separate this and rewrite it ever so slightly. So I'm going to say that this is equivalent to cos theta, and we're going to multiply this by cos theta divided by sine theta. So going from here to here, we've not actually done any or used any identities. We've simply just kind of effectively split our cos theta squared into 2 individual ones. So then we can see we now have this cos theta here. So then the next trig identity we can use, we know that cos of theta divided by sine of theta, which is what we have here, we have that this is going to be equal to cot of theta. So therefore we can substitute this back in, and what do we have? Well, we have is going to be equivalent to cos of theta multiplied by cot of theta. So therefore, this is the required answer. This is what the question wanted, and we've shown that cosec of theta minus sine of theta is equivalent to cos theta multiplied by cot theta, and this is as required. So this question was worth 3 marks, and where did we pick up our 3 marks? So we receive our first mark for either stating and using the trig identity that cosec theta was equal to 1 over sine theta. We then get our second mark for substituting this in and then combining our fraction to be a single term. So that was at this stage here when we had 1 minus sine squared theta over sine theta. And then we receive our third and final mark for following through with the rest of this and coming to the correct conclusion which the question asked for. So now in part B of the question, we're asked hence or otherwise solve between 0 and 180 degrees that cosec of x minus sine of x is equal to cos x multiplied by cot 3x minus 50. So recall from part A, we know that cosec theta minus sine theta is equivalent to cos theta multiplied by cot theta. So therefore, we can use part A and we can say that cos of x multiplied by cot of x is going to be equal to, so effectively we are given here this left-hand side and we know that is equal to this. And then this is good because we have a cos on either side, which means we'll be able to cancel them out. So we can say that cos of x multiplied by cot of x is going to be equal to cos of x multiplied by cot of 3x minus 50. So now what we can do, we notice that we have a cos x on this side and a cos x on this side. So we're going to divide by cos of x and we're going to divide by cos of x. So this is going to therefore leave us with the fact that cot of x is going to be equal to cot of 3x minus 50 degrees. So therefore, we can see that then we're going to have the x is going to be equal to 3x minus 50 degrees. And this is just from the fact that these coefficients are the same. So we have cot on both sides. So therefore, from this, we'll just write in here that these are equal, if you like. So then we have, therefore, that x is going to be equal to 3x minus 50. So we can then solve this. We can say that, therefore, 2x is going to be equal to 50 degrees. And therefore, x is going to be equal to 25 degrees. So then we also know that since cot x has a period of 180, we'll be able to find a second solution. So how are we going to do this? So we'll just note that down. We'll say that since cot x has a period of 180, we can find a second solution. How are we going to do this? So we're going to therefore have our second solution is going to be found as follows. So we have x plus 180 is equal to 3x minus 50. So we just add our 180 here, and that's due to the period being 180. So therefore, what is this going to be? This is going to be 2x is going to be equal to 230. So therefore, x is going to be equal to 115 degrees. So therefore, we found the second solution. And then we must also take into account the solution when cos x is equal to 0. Why is this? This is because, remember, in our original term, we have a cos x. Hence, therefore, we'll have the solution when cos x is equal to 0. So we'll just note down here, there will be a third solution when cos of x is equal to 0. So therefore, we'll have that x is going to be equal to cos negative 1 of 0. And putting this into our calculator, we'll therefore have that x is going to be equal to 90 degrees. So therefore, just concluding on all of this, we'll have that x is equal to 25 degrees, x is equal to 90 degrees, and our third solution, which we found, x is equal to 115 degrees. And therefore, we've completed this question. Looking back, this question was worth 5 marks. We received our first mark for getting to the stage where we had x is equal to 3x minus 50. And we then receive our second mark for getting our first solution, which was x equal to 25 degrees. We then receive our third mark for identifying that this will be another solution due to the period of cot x, which we get here. And then we receive our fourth mark for finding this second solution. And we then receive our fifth and final mark for knowing that there'll be this cos x equals 0 solution and having that x was equal to 90 degrees. And we've therefore completed this question.